Hi, and welcome to my channel. If you're new here, just as a summary, I'm going through the GCSE Edexcel Maths Higher 91 syllabus. You can also use my videos if you are doing the foundation as well. I will try to define which videos are specifically for the higher syllabus. So in this video, we're going to continue with part 2, expressions, and this is video 2.2, Indices Introduction. So we're starting with the indices because we need to be able to get the knowledge to handle the indices in order to solve more complex expressions and equations. So let's begin. Indices, otherwise known as powers. So to start off with, we're going to say, so this is like the rule. So index is the singular version and indices is the plural version. Okay? And indices is the same as powers, and which is the same as orders. So don't get confused with that. You might see in my last video I talked about the bid mass, and uh, people sometimes use something called the BODMAS as well. So that's BIDMAS use indices and BODMAS use orders. So just remember, index is singular, indices is plural, indices is the same as powers, which is same as orders. I I showed you this because usually down the line during my GCSE times, most of us were really confused with what an index was or an indices was because we thought they were completely different things because we haven't been taught this. So I'm showing this here to you now. So don't get confused. They're just the same thing. Okay? Now, so what actually is an index or indices? Well, indices, in basic terms, is how many times a letter or a number is multiplied by itself. Note, in this definition, the keywords to look out for is multiply and itself. So if you do any other thing, so for example, if it's addition and if it's addition and if it's not the same, uh, if it's addition and the same number or letter, then that would not be right for you to use indices. Or if it's multiplication but it's a different number or letter, these indices would not be involved in there because it would be wrong. So let's look at further. So an index has the form of, usually an index has this form. So what I mean by form is the number usually looks something similar to this. So A and N, they're two different just letters that I picked out, but you can substitute in the numbers for A and the N. So where it says A, okay, the A is called the base. So this is the number or letter that we are multiplying by itself. And N is called the power. And the power, the number of times that something is being multiplied by itself. So please note, N can be either plus or minus, and it can also be a fraction. So in this video, because it's an introduction, we are only going to look at the plus or minus, and later down the course, we're going to look at the fractions and the roots and everything, because this is just the introduction. Because we need to have the enough knowledge in order to complete the expressions and expressions and equations, but we need to know the other indices knowledge later down the line. So we'll worry about that later. Okay, so let's move on. So here's an example. So when I say it's being multiplied by itself, so let's look at when n equals 1 of the form a to the power of n. So when n equals 1, it's the same as saying a to the power of 1, which is equal to a multiplied by 1, which is also the same as just saying a. Because with everything, when any number or letter is to the power of 1, it's always that number or letter. So technically speaking, when we're writing, I don't know, some random number like 23, it's the same as writing 23 to the power of 1. We don't usually write the power of 1 because it's kind of pointless. It's just 23. So it's much more easier to use a to the power 1 is same as a, so it's much more easy to use a than writing a to the power 1 each time. So now let's look at n equals 2. When we say n equals 2, we mean a to the power of 2, which is the same as saying a multiplied by a. So it's a times a, which is itself times itself. So you do it 2 times. Let's look at when n equals 4. So this is same as saying a multiplied by a multiplied by a multiplied by a. So this tells us that a is being multiplied by 4 times. So this number on top here, it tells us how many times this base number is being multiplied by itself. So naming. So how do we actually name them? Well, there are 2 ways of naming. The first is A is a specific name that you need to remember. And the second is you can just say A to the power of n, where you can substitute in the value for A and n depending on what the question is. So when naming, you can use either of them. So there's no specific rule on you have to use this or you have to use this. You can use either of them. It's better to know both, but yeah, let's take a look at each one. So specific names. So here are some specific names. So when n equals 2, squared, because a is squared. When n equals 3, we say a is cubed. When n equals 4, we say a quartic, or a is quartile or something. Hold on. Well, for the n equals 4, there are actually a few names there. So it's like biquadrate and biquadratic and quartic. So it just gets a little weird after that. So here are some few examples for the specific names, and let's look at the other one. So this one is just a to the power of n. So you can replace the value of a and n. So for example, we can say when n equals 2, we say a to the power of 2. When n equals 3, we say a to the power of 3. Or when n equals 100, we say a to the power of 100. So if we take a look at it in the context, and then we say a equals 3, and then n equals 5. So we say 3 to the power of 5. So it's pretty simple and quite straightforward. Most of the time I prefer to say in this way because I don't forget, and because most of the time I would usually forget what if it's quartic or quadratic and whatever. So I would tend to use this one than the previous one. But most of the time in mathematics, when we're talking, we usually use squared and cubed because they're quite easy things to remember. But after power of 3, which is cubed, you just say power of 4, power of 5, and etc. Okay, so we've done the naming now. So we need to move on to rules. So like with everything, there are a few rules you need to know. At the moment, I'm only going to show a few, but later down the course, I will introduce other rules, and I will make a revision video for each topic. So you can easily you can use it just before your exams are due. Okay, so rule 1. The multiplying of the same base, you add indices. The multiplying of the same base, you add the indices. So what does this mean? It means is this. So a and a, these are the same base, and x and y, they're 2 different indices. So when a to the power of x is being multiplied by a to the power of y, it is the same as saying a to the power of x plus y. So there is a proof for this, but now looking at the proof now would not be helpful because to be honest, you do not have enough knowledge to understand the proof. So the proof is A-level content. So when I make the A-level content, I will definitely show this to you. So just remember these rules and it will be much easier. And then I will show you how to use these rules one by one. So rule 2. Dividing of the same base. subtract indices. So dividing the same base, subtract the indices. Here's another example. We do a to the power of x divided by a to the power of y, which is the same as a to the power of x minus y. So rule 3. Finding the power, you multiply the indices. Finding the power, you multiply the indices. So what does it mean? This means that when you have a to the power of x, you do bracket and power of y. So this is the same as saying you have 8x and then you do that to the power of y. So a to the x, the whole thing, and you do it to the power of y. That's the same as saying a to the x multiplied by y. So these are the 3 rules that you need to know. And these are 3 rules that you should really remember. But before you do anything at the start, you need to deal with the coefficients. The coefficient is the number in front of the variable. So, for example, rule 1 is this. So B and C, they are the coefficients. So as you can see, because it's being multiplied, you do whatever this operation is, you do it to these coefficients here. You do it the same way. So B multiplied by C, or B divided by C, or B to the power of Y. But, okay, let's look at an example. What we're going to do is 3x squared multiplied by 12x to the power of 6. Now you can pause the video and have a go at yourself. Or if you would like to stick around and then watch me do it, then we shall start. So in this thing, first thing you need to do is coefficients. Always deal with the coefficients first, because I always like to separate this out into 2 sections. 1, coefficients, and 2, indices. So deal with the coefficients first. First is you have 3 times 12. So 3 times 12 is 36. So we leave that aside. Now we move on to indices. Now we have x squared multiplied by x to the power of 6, which is the same as using rule 1. They say when it's the same base and it's being multiplied, you add the indices. So you do x to the power of 2 plus 6. So 2 plus 6 is the same as is 8. So you have x to the power of 8. Now what you do is you just bring them both together. So the answer for 3 squared multiplied by 12x to the power of 6 is 36x to the power of 8. So this is the answer. Now we're going to still looking at rule 1, but this time we're going to have a minus value for the indice. So dealing with the coefficient, same as last time, the coefficient doesn't change, 36. Now so let's look at the indice. So indice slightly changes because it's x squared times x to the minus 6. Because it's the same base and it's being multiplied, you add the indices. So 2 plus minus 6. Minus 6 goes as one value. So you add the minus 6. Because you're adding minus 6, it's the same as saying 2 minus 6. Okay? So because you're adding is same as saying 2 minus 6. So when you simplify that, it becomes x to the power of minus 4. And now what you do is you just put them back together, and the answer is 36x to the power of minus 4. So that's the answer for this question. Let's look at rule 2. This is example 4. So the same as before, you can pause the video and then have a go at yourself, and then play the video to see if you got the answer correct. So I'm going to be moving straight on for the others. Okay, so for this one is you have 3x to the power of 12 divided by 15x to the power of 4. So, like always, do with the coefficients first. The coefficients, you do 3 divided by 15, which is the same as writing 3 over 15, which is equal to 1 over 5. So these I wrote in the fraction form, but because it's much easier for me. But I will show you a much nicer and much easier method to find this fraction form in a later video. So we split this here into indices part, so that's the second phase of it, and then we do this. So because this is the same base, with the so same as before, what we do is we have, because it's the same base and it's being divided, we use rule 2. Rule 2 says if it is the same base and it's been dividing, you subtract the indices. So now what you do is you do 12 minus 4, because you subtract the indices, which is equal to x to the power of 8. Now, same as before, you bring these two together. So the answer is 1 over 5 x to the power of 8. So rule 2, doing this again. So this time we're going to do the same question, but we're going to have the minus 4 up here. To deal with the coefficients, so we know that's 1 over 5, it's not going to change. Now, indices part. So we're going to do to the power of 12 divided by x to the power of minus 4, which is same as saying x to the power of 12 minus 4. Remember, you must keep this minus there, because that's where most people go wrong. People always go, oh yeah, because I have minus here, just forget this minus here. No, that would give the wrong answer. Because if you think about it, if you miss out this minus here, and then you would just be left with 12 minus 4, which is the same as the answer above. But now this answer is different. As you can see, x to the power of 12 minus 4 is the same as saying 12 plus 4, because minus minus makes plus, which is the same as saying to the power of 16. The answer is 1 over 5 x to the power of 16. Let's look at example 6. This is rule 3. So this is power, using the power. So first you need to look at the coefficient. When looking at the coefficient, it's going to be 5 to the power of 3, which is the same as saying 5 times 5 times 5, which is the same as saying 25 times 5, which is 125. The indices, the x to the power of 4 bracket to the power of 3. So when it's being powered, you do x to the power of 4 multiplied by 3, because the indices multiply. So which is the same as saying x to the power of 12. So now you bring the coefficient and the indices together, which gives the answer of 125 x to the power of 12. Now let's look at the minus 3. So look at the coefficient and look at the coefficient. So minus 3 means you flip it round down. We will look at this clearly in a later video when we're looking at the indices and how in more detail. So just bear with this for the time being, because usually when you say a minus indices something whatever here, you just flip the number. So you have, if you have 5 here, then you would have 1 over 5. Or if you had 1 over 5 here, then you would then you would have 5 here. So because it's 5 to the power of minus 3, you bring it down, so it becomes 1 over 5 to the power of 3, which is same as 1 over 125. So now looking at the indices part, So it's the same as before, but the only difference is instead of doing 4 times 3, you do 4 times minus 3, which is minus 12. Now combining those two together, you get 1 over 125 x to the power of minus 12. In summary, in this video you have learned what is an index as an introduction. So these are the rules for using the indices. So when the same base is being multiplied, you add the indices. When same base is divided, you subtract the indices. When the base is made to the power, you multiply the indices. So these are the main three things you need to remember and understand quite clearly, because this is the main knowledge that we're going to take on to solve our other examples and other questions in expressions, equations, and this is quite a fundamental thing. So learn these rules pretty much off by heart and do some practice questions, and you'll be okay. So in the next video, we will be continuing with the same thing. To so it's going to be part 2 expressions, and we'll look at more questions on how we are actually going to be using these indices in those questions. Well, thank you for listening, and I really hope you enjoyed this video. And if you did, please like this video and subscribe. Also, let others know of this channel so you can pass on my help to other students as well. So if you have any questions or any things that you want to let me know or talk to me about, please leave your comments below. And if it's your first time here, make sure you check out my playlist on the GCSE 91 full course content in my channel. Well, thank you for listening, and I will see you next time. Thank you. Bye.